In today's session, we are going to see whether the given function satisfies the given differential equation or not. Hi, I am Syed. Welcome to my channel, Educate with Syed. Let's get started. In the previous video, we had solved few of the problems on this particular topic. So we'll continue with few more problems on the same topic. The next question is xy is equals to log of y plus c, and the differential equation is y dash is equals to y square by 1 minus of xy. It is given that xy is equals to log of y plus c. Let us try to differentiate this with respect to x. So since you have the product of two functions, we can take the first as u, next as v. So we'll try to use the product rule over here, u into v dash. So differentiation of y with respect to x will be dy by dx, u into v dash plus v into u dash. Differentiation of x with respect to x will be 1 is equals to, on the right hand side, derivative of log differentiation will be 1 by, so we'll be getting 1 by y into differentiation of y with respect to x will be dy by dx plus the differentiation of this constant will be 0. So let's rewrite this as x into dy by dx plus y. Now since you have dy by dx on this side also, let us take this value on the left hand side. It is a positive value. When it comes on the left hand side, it becomes negative. 1 by y into dy by dx. On the right hand side, you are left out with 0. Now let us try to group this two. You have dy by dx as common outside. So if I try to remove dy by dx as common, then we are left out only with this x value over here minus of 1 by y value. We can send this value of plus y on the other side, that will be equals to minus of y. Or I can rewrite this as dy by dx is equals to minus of y. This value can just cross multiply, it becomes divided by x minus 1 by y. Now you can take the LCM over here in the denominator, numerator as it is, whole divided by. Now I can just take y as the LCM. So if you take y as the LCM, just try to cross multiply this one. So x into y will become xy minus of 1. Or we can rewrite this as minus y, and this denominator value, when I take that to the numerator, it becomes reciprocal, it becomes y by xy minus of 1. Or further, if you try to multiply this one, minus as it is, y into y will become y square. It is whole divided by xy minus of 1. If you try to compare this with the given differential equation over here, it is y square in the numerator you have, in the denominator it is in the form of 1 minus of xy. But here you are having xy minus of 1. So it is better we try to express this as 1 minus of xy. For that, I'll take negative sign outside and write this value as 1. And because this is a positive value, negative value is already taken. So minus of minus will become plus there. So 1 minus xy. We see that this negative value and this negative value will cancel out, and we are left out with dy by dx is equals to this y square divided by 1 minus of xy. But dy by dx can be written as y dash. Therefore, we have verified y dash is equals to y square divided by 1 minus of xy. Hence, the given function verifies this given differential equation. The next question is y minus cos y is equals to x, and the differential equation is y sin y plus cos y plus x times of y dash is equals to y. Given the function y minus cos y is equals to x. Let us try to differentiate this with respect to x. Derivative of y with respect to x will be dy by dx minus cos of y, differentiation will be minus sine of y, into differentiation of y with respect to x will be dy by dx. And on the right hand side, differentiation of x with respect to x will be 1. Rewriting this as dy by dx, this minus of minus will become plus sine of y into dy by dx is equals to 1. If you try to observe over here, dy by dx is common. So let us take dy by dx as common outside. So we will be left out with 1 here, and here sine of y. This will be equals to 1, or dy by dx will be equals to, you can just cross multiply this one, it becomes 1 by 1 plus sine of y. Now we will just try to take the left hand side value and substitute the value of y dash and try to get the right hand side value. So this dy by dx is nothing but your y dash. So let us take the LHS. LHS is what? Y sine of y plus cos of y plus x times of y dash. So this is y sine of y plus cos of y plus x as it is times of y dash. Y dash is 1 by 1 plus sine of y. Go back to the question over here, the value of x is given as y minus cos y. So we'll try to replace x value as y minus cos y. So you can write down from the question, right? From the question we have the value of x to be equals to y minus cos of y. So if we try to plug in that value over here, so we have LHS to be equals to y sine of y plus cos of y plus x value over here is y minus cos of y times of 1 by 1 plus sine of y. So you can cancel out this positive cos of y and negative cos of y. So we are left out with y sine of y plus y times of 1 by 1 plus sine of y. Further, if you try to observe over here, y is common, you can remove y common outside, then you are just left out with sine of y plus, because y is taken common outside, you are left out with 1 times of what you have, 1 by 1 plus sine of y. Sine y plus 1 and 1 plus sine y both are the same, they will cancel out. We are left out only with y, which is nothing but the RHS. So hence we have LHS is equals to RHS. That's the required solution. So the next question is x plus y is equals to tan inverse of y, and the given differential equation is y square y dash plus y square plus 1 is equals to 0. So given the function x plus y is equals to tan inverse of y. Let us try to differentiate this with respect to x. So differentiation of x will be 1 and differentiation of y with respect to x will be dy by dx is equals to differentiation of tan inverse will be 1 by 1 plus, here y is there, it becomes y square. So tan inverse of y will be 1 by 1 plus y square into differentiation of this y with respect to x will be dy by dx. Now let us try to group this dy by dx value, keeping 1 as it is. I will try to send this dy by dx on the other side. We have 1 by 1 plus y square into dy by dx. So this plus dy by dx, when it goes on the other side, becomes minus dy by dx. So we see that we can take this value of dy by dx as common. So you'll be left out with 1 by 1 plus y square, and this is minus of 1. Let us take the LCM over here. Dy by dx as it is, the LCM is 1 plus y square. So this 1 as it is, just cross multiply this 1 plus y square on the other side. It becomes 1 plus y square. We see this plus 1 and this minus of 1 will cancel out. We are left out with the dy by dx times of, over here it is minus of y square is taken, divided by 1 plus y square. This 1 will remain as it is. Now, keeping this dy by dx as it is, you can just cross multiply this one. 1 plus y square into 1 will be 1 plus y square. Similarly, cross multiply this one, divided by minus of y square is equals to dy by dx. Therefore, rewriting this one, dy by dx will be equals to, with a negative value, minus of 1 plus y square by y square. You can just substitute this value of dy by dx back in the given differential equation. Your dy by dx is nothing but y dash. So this dy by dx is nothing but your y dash value. Therefore, let us take the LHS side of the given differential equation, which is y square into y dash plus y square plus 1. So y square as it is, y dash is this particular value. So if I try to write down, it becomes minus of 1 plus y square whole divided by y square, plus this y square as it is and this plus 1 as it is. We see that this y square and y square will get cancelled. Now you can just multiply this minus inside, minus of 1. This is minus of plus will become minus y square. And these two terms, plus y square and plus 1, will remain as it is. We see that minus y square and plus y square will get cancelled. Minus 1 and plus 1 cancels out. And we are left out only with 0, which is nothing but the RHS of the given differential equation. Hence, we have verified the required solution. Hence, we got LHS is equals to RHS. So, the next question is y is equals to square root of a square minus of x square. X belongs to minus a comma plus a. And the given differential equation is x plus y into dy by dx is equals to 0, provided that the value of y is not equals to 0. Given the function y is equals to, it is root of a square minus of x square. Let us try to differentiate this one with respect to x. So derivative of y with respect to x will be dy by dx is equals to, now square root differentiation. Root differentiation will be 1 by 2 root. So 1 by 2 root of what you have, a square minus of x square into the inner differentiation of a square minus x square. A square differentiation will be 0 minus x square differentiation will be 2 times of x. Therefore, I can rewrite this as minus of 2x, ignoring this 0, divided by 2 times of root of a square minus of x square. We see that this 2 and 2 will get cancelled. We are left out with minus x divided by root of a square minus of x square. Now let us take the differential equation. LHS of the given differential equation is x plus y dy by dx. It's given that x plus y dy by dx. So I have to show that it is equals to 0. So this will be equals to x plus y. What is dy by dx over here? Minus x divided by root of a square minus of x square. But we know the value of y from the given question. So what's the value of y from the question? It is root of a square minus of x square. Substitute the value of y is equals to root of a square minus of x square there. We will be getting x plus root of a square minus x square times of this value minus x by square root of a square minus of x square. We see that square root value will get cancelled. We are left out with x, and this is plus into minus will be minus of x. So this plus x and minus x will get cancelled. We will be getting the value to be equals to 0. So hence we have LHS is equals to RHS. Therefore the differential equation is verified. The next question is the number of arbitrary constants in the general solution of a differential equation of fourth order are: a bit is 0, b bit is 2, c bit is 3, d bit is 4. We have one result: number of arbitrary constants in a general solution is equals to the order of the differential equation. If you try to observe over here, the number of arbitrary constants in a general solution is nothing but the number of arbitrary constants in a general solution is equals to what? Is equals to the order of the differential equation. Here we have the fourth order differential equation. Therefore the order of the given differential equation is 4. Then we can conclude that the number of arbitrary constants in a general solution is equals to 4. Therefore option number D is the right option. The next question is the number of arbitrary constants in the particular solution of a differential equation of third order are. So the previous result was number of arbitrary constants in a general solution. Now we are talking about the number of arbitrary constants in a particular solution. But we know that a particular solution does not have any arbitrary constants. So in a particular solution the number of arbitrary constants are 0. So the number of arbitrary constants in a particular solution are 0. Therefore option number D is the right option. That's the required solution. If you like my video, please subscribe to my channel. That's all I have for today. Thank you.